Hey there, welcome to What the Physics. We're going to look at recognizing those values, those properties within those mathematical equations. For example, when we have a position time graph like this, that is a linear line, then we had y equals mx plus b. Linear model. Sorry. So you have x equals velocity times time plus initial position. So all those pieces work out to be units of length. So in that model, there are two terms, and you can see the velocity is units of meters per second. Here's an example. Say position is negative 5 meters per second times t plus 2 meters. Well, the object starts at 2 meters and moves to the left with a constant velocity of 5 meters per second. All right? If time equals 3, then x will equal negative 5 meters per second times 3. The seconds cancel. That comes out to negative 15 plus 2. Hey, negative 13 meters. So we can actually figure out where something goes. Pretty cool. What about something else? What happens when we have a curve like this with position and time? Well, we found a new model, the quadratic. Y equals ax squared plus bx plus c, where y is position. A is 1/2 the acceleration, t squared, plus the initial velocity times time plus the initial position. So the position is going to be half of the acceleration times t squared. And the next term is going to be initial velocity times time. And the last one is our initial position. Note, all those terms have the same units. Each term will end up in meters. Here's an example. X equals 5t squared minus 4t plus 2. Well, that means you have 5 meters per second squared times t squared minus 4 meters per second times t plus 2 meters. That means half the acceleration is 5, which means the acceleration is actually 10 meters per second squared. Our initial velocity, you just read it right off of there, and same thing with our position. So an object starting at 2 meters, going to the left, initially at 4 meters per second, accelerates at a constant rate of 10 meters per second squared to the right. Crazy, right? All of those things line up back. Okay. The general position equation, then, is the most complicated one, right? Position is equal to 1/2 the acceleration times time squared plus initial velocity times time plus initial position. Sweet. Let's take a look at some cases. In case 1, let's say acceleration is 0 meters per second squared, so our velocity isn't changing. In other words, the object is not accelerating. So object moving with a constant velocity. Okay. What about case 2? What about initial velocity being 0? Okay, well that means the object is accelerating from rest. Case 3. What if position initially is 0? Well, that just means the object is accelerating from some position of 0. Sure, that works. Another case would be, what if the initial velocity was 0 and the position was 0? Well, then the object is accelerating from rest from 0 meters. There you go. What would that look like if we had another equation? Let's try this another one. Y equals negative 5 meters per second squared times time squared plus 10 meters per second times time plus 2 meters. Whew. All right. Well, if we look at that, position and time graph, what if we wanted to sketch it? Okay, well, let's start 2 meters down here. 10 gives us the angle. It's very steep there. And then we figure it's going to take us some time to slow down from 10 meters per second. In fact, in 1 second, we're going to slow down to 0. And then 2 seconds will be going negative. So our curve works out that way. Kind of cool that you can draw it by just sketching out what is going to happen. Now, notice that this negative number tells you which way the parabola goes. If it's positive, it'll be concave up. And if it's negative, it'll be concave down. Cool. So that's positive acceleration and negative acceleration, respectively. Pretty cool. This one tells you the initial steepness of the graph. So if it was positive, it's very steep. If it's negative, it's steep and downwards. And then this one is kind of where you start the graph. Okay. So if you wanted to sketch a graph, you could do it pretty easily. Well, let's look at this one. What about y equals 5 meters per second squared t squared? Oh, notice that's like our case before where velocity was 0 and initial velocity was 0 and our position was 0. So let's take a look. Remember what the acceleration is. We have to double that. 10 meters per second squared. I'm thinking about, oh, there's no term, so that must be 0 for both of those things. Okay, that means my initial velocity is flat, right? It's flat curve, and then it curves up from there because it's a positive concavity. All right, what about y equals t squared plus 5? What's the acceleration? What's the initial velocity? And what's the initial position? Well, remember our model. We apply that to our model and say, hey, 1/2 at squared is t squared, so a equals 2 meters per second squared. Initial velocity, there isn't a term, so 0. And initial position is 5. So this would look like we'd start it with a positive concave. It would be flat at the beginning, and it would start up high, and it curves away, just like that. Cool. What about x equals negative 3.5 t squared plus 21t? What's the acceleration? What's the initial velocity? And what's the initial position? Yep, you got it. Negative 7 meters per second squared, so it means concave down. 21 meters per second for initial velocity, and there's no term, so it must mean initial position is 0. So we're going to start, what if we draw that? It would start at 0. Right? We're going to look at two graphs, position in time and velocity in time. It might actually be easier to draw the velocity graph first. So we're going to draw it from 21 going downward, crossing the x-axis there, the time axis at 3 seconds. How do I know? Well, 21 minus 7, 3 times gives me 0 velocity. So that's where it's going to be flat. So I'm going to initially go up and then back down. So I'm going to be going the same steepness at the beginning and end of that in 6 seconds. Kind of cool. Check out one more. Y equals 7t minus 2. What's the acceleration, initial velocity, initial position? Oh, no, it's not 14 because that term is not there. So it's actually 0. So we got to be careful. We got to look at those terms. Initial velocity is the coefficient in front of the t. That's 7 meters per second. It doesn't curve, and initial position is negative 2. So on my position time graph, I'd start down here and go up at an angle so that the slope is 7 meters per second and constant. Pretty cool, huh? Let's take a look at the velocity graph. It's constantly 7 meters per second. Yep, you got it. The slope of 0 meters per second squared, and as that 7, it goes across. What about the velocity model? Well, we have v equals at plus v initial. That's a linear model for velocity. Well, velocity is acceleration times time plus the initial velocity. Notice that there is no initial position at all on this one. That means we can only tell you two things, acceleration and initial velocity. So let's say we have one, Vy equals negative 10t plus 5. Acceleration, I just read the numbers, negative 10 meters per second squared, initial velocity 5 meters per second. So if I were to do my velocity time graph, I know that I'm going to be drawing a negatively sloped line. And by the way, that little y says that this vertical velocity, but you can put anything you want there. Our initial position, we don't know. We can't find it out because we just don't know. So there's our graph. If we look at our time graph, we have zeros. We have a nice little t-table we can do to find out when 0 is and just to make sure we're drawing our line correctly. What about this one? V equals 2t. What's the acceleration? What's the initial velocity? And initial position? 2 meters per second squared, 0 meters per second, so there's no term, but we still don't know a position. We can't do it. We can't do position. So if we were to graph that, it's going to be going from 0 upwards at an angle such that the slope is 2 meters per second squared. Oh, the bonus round. Ooh. V equals 5. What's the acceleration and what's the initial velocity? No, acceleration is not 5. It's 0 because there's no term, no t term. And initial velocity is 5. What about this one? V equals 2t plus 4. Well, with an initial position of negative 2 meters. Well, we can put all this together like we were doing before, but now we have that little piece so we can put it in, and so we get our quadratic equation. Very cool. Thanks a lot.